Welcome to Homework Lib.
All right, we want to find the perimeter of this jack-o'-lantern. Anything that is a straight part, like the bottom here, we can just add up. So, like this is 5. We've got that accounted for. I'm going to go ahead and do that with all of we'll call those the easy parts here. That's 3. This is 1 here. All the vertical and horizontal parts. Now, anything that's diagonal, maybe you use the distance formula, or maybe you use Pythagorean theorem. The Pythagorean theorem would just mean all of these act as a hypotenuse of a right triangle, every single one of these. And the way you can quickly calculate their lengths is with the Pythagorean theorem, where it's the square root of that c value is every one of those lengths of your horizontal and vertical move. For instance, if we're going over 2 and up 1, that's 2 and 1 under the Pythagorean theorem. And so that would be the square root of 2 squared plus 1 squared is 4 plus 1, or 5. So we'd say this is the square root of 5. In the next one, we're putting 1 and 1 into the Pythagorean theorem. And the square root of 1 squared plus 1 squared, 1 plus 1 is 2. This is the square root of 2. We've got another 1 and 1 into the theorem. So that's going to be square root of 2. 1 and 2 into the theorem is going to be another square root of 5. Another 1 and 1 is going to be square root of 2. Another square root of 2 here. Another square root of 5 here. And another 1 and 2 into the theorem is square root of 5 again. Square root of 2. And square root of 5. So let's get if we're doing this exactly, let's add up our 5 plus 2 is 7, 8, 9, plus 3 is 12. We've got 13 plus how many square root 5s? We've got 1, 2, 3, 4, 5 square root 5. So we can say it like that, 5 square root 5. And then we have 1, 2, 3, 4, 5 square root 2s. We can't combine the square root 5 and square root 2s because they're different radicals. This would be our exact perimeter.